Hi all. Today we can discuss about some CSIR NET and GATE questions that ask from the topic Cauchy Riemann equations. In the last video, we have discussed about analytic functions, Cauchy conditions for the function to be analytic, Cauchy Riemann conditions, etc. So we know that if function is analytic, the necessary and sufficient conditions are, first of all, it must have first order partial derivative with respect to the variables, and it must obey the Cauchy Riemann equations. So what are the Cauchy Riemann conditions? One is dou u by dou x equal to dou v by dou y, and dou v by dou x equal to minus dou u by dou y, where u is the real part of the analytic function and v is the imaginary part. So we can see the first question. This question asked in NET June 2012. So the question is, let uxy is equal to x plus half x square minus y square be the real part of an analytic function f of z of a complex variable z equal to x plus iy. The imaginary part of f of z is. So in the question, it is given the real part. Okay, so what is the real part there? U is equal to x plus half into x square minus y square, and it is also mentioned that the function is analytic. So the function is analytic means we can apply the Cauchy Riemann equations there. So what we have to find out there? We have to find out the imaginary part. So what is imaginary part? We have to find out. So how to find out the imaginary part? We know that to find out the imaginary part, we have to take the total derivative of that part there, that is dv is equal to dou v by dou x into dx plus dou v by dou y into dy. So we don't know the dou v by dou x, dou v by dou y, but we can apply the Cauchy Riemann equations there. So what are the Cauchy Riemann equations? That is dou v by dou x is minus dou u by dou y. So here we can write it as minus dou u by dou y into dx plus dou v by dou y. What is dou v by dou y? According to Cauchy Riemann equations, it is dou u by dou x into dy. That is equal to u is given, so we can find out the total partial derivative with respect to x and y. That is dou u by dou x is equal to, it is u equal to x plus half x square minus y square. So dou u by dou x is 1 plus, here it is half into 2x, that is x. Okay. So similarly, dou u by dou y. So what is dou u by dou y? Dou u by dou y is equal to half into minus y square derivative is 2y. So minus 2 will cancel and we will get minus y. So just we can substitute here minus dou u by dou y. Dou u by dou y is minus y, here minus 1. Therefore it becomes plus y dx plus dou u by dou x into dy. So what is dou u by dou x? Dou u by dou x is 1 plus x into dy. Okay, this is dv. Okay, so now here the next step, what we have to integrate, what we have to do, we have to integrate this. So before integrating, we can see that this is with respect to x, but y variable is here. Here is y is there, y is there, but x is here. So we can combine that. That is here y dx. Here it is x dy. That is, it is the d of xy. Okay, that is x into dy plus y into dx. Plus one term extra is here 1, so that is 1 into dy. Okay, here it is dv. Now we can easily integrate this, integral. Okay, on integrating. So what we are getting, v is equal to integral of differential of xy, that is xy, plus integral dy, that is equal to y. So the answer is v is equal to xy plus y. That is our option A. Okay. The next question is asked in June 2013 CSIR NET examination. Here the question is, with z equal to x plus iy, which of the following function is not a complex analytic function of z? Four options are given. So what we have to find out in these four options, which function is not analytic. So in order to find out a function is analytic, we have two conditions. First of all, it must have first order continuous partial derivatives. Second is it must obey Cauchy Riemann conditions. So here, in order to apply these Cauchy Riemann conditions, it is time consuming. But so we can use a shortcut here. Here we know that Z is equal to X plus IY. Okay, so what will be its complex conjugate? Z star is equal to X minus IY. Usually, if a function consisting of Z star, that is not analytic, because Z star conjugate of the Z is not analytic. So, if we check in these functions, which function consisting of the terms Z star, then we can confirm that that function is not analytic. If it is Z square, that is analytic. That is Z square is X square minus Y square plus 2IXY, that is analytic. But if a term consists of Z star, that is not analytic. See the first option in this X plus IY, that is Z minus, what is Z? Z equal to X plus IY. Z minus 8 whole cube 4. Here it is minus X square minus Y square plus 2IXY. Okay, sorry, this is plus X square. The option it is plus. Okay. So here we can see that this is X square minus Y square plus 2IXY, that is Z square. Okay, so this term not consisting of Z star term, that is this function is analytic. Next one is, this is X plus IY, that is Z raised to 7 into 1 minus, if you take the minus term outside, this will be X plus IY, and is X plus IY is Z only. So this is 1 minus Z all cube. So no complex conjugate there. Now in this question, it is equal to X square minus Y square plus 2IXY, that is Z square. So this is Z square minus 3 all raised to 5, and the last option, it is 1 minus X. If you take the minus term outside, so that is X minus IY. That is, what is this X minus IY? Z star. So this is 1 minus Z star raised to 4 into 2 plus Z raised to 6. So in the last option, option D, it have a term of Z star, a complex conjugate term is there. So we can say that this function is not analytic. Okay, so randomly we can check if any term consisting of an complex conjugate, then we can confirm that the function is not analytic. Okay. Next question asked in December 2013 CSIR NET examination. The question is, which of the following functions cannot be the real part of a complex analytic function of Z equal to X plus IY? Here we can apply the concept of harmonic functions. That is, we seen that if a function is analytic, the real part and imaginary part obeys Laplace equation. Okay, if the function is analytic, then U and V obey Laplace equation. Okay, that's why we said that U and V are harmonic function. They are harmonic conjugate. What is Laplace equation? Laplace equation is dou square U by dou X square plus dou square U by dou Y square is equal to 0. Okay, in this question they are asking about the real part of complex analytic function. Even if it is the imaginary part, then also that also obey this Laplace equation, because the real and imaginary part of an analytic functions are harmonic function. That means they obey the Laplace equation. So only just we have to check in these four options which obeys this equation. That function, that part will be the real part of that function. So take the first function. If U is equal to X square Y, so what will be dou U by dou X? Dou U by dou X is equal to 2xy, and what is dou U by dou Y? That is equal to X square. Then what is dou square U by dou X square? It will be 2y, and what will be dou square U by dou Y square? That is equal to 0. So if we substitute in this expression, that is dou square U by dou X square is 2y plus x dou square u by dou y square is 0 is equal to, it is not equal to 0. So that means it do not obey Laplace formula. Okay, so Laplace equation, that means this u is not a real part. Okay, so from the first option itself we got that this x square y is not, in this question it is asking which of the following function cannot be the real part of complex function. So x square y is not the real part of this complex function. We can if you want we can check the other conditions too. For example, if we are taking u is equal to x square minus y square b part, then what will be dou u by dou x? Dou u by dou x is 2x, dou u by dou y is equal to minus 2y. So if you are taking the second derivative, this will be 2x derivative is 2. If you are taking the second order derivative here, this is minus 2. So on substituting here, what will we are getting? Dou square u by dou x square plus dou square u by dou y square is equal to, what is that? This is 2, this is minus 2, that is equal to 0. That means this function is analytic. This is the this obeys the Laplace equation, and therefore this will be the real part of the equation. So this question asked in June 2017 net examination. Let uxy is equal to e raised to ax cos by be the real part of f of z equal to u plus iv of a complex variable z equal to x plus iy, where a, b are real constants, a not equal to 0. The function is analytic if and only if b equal to 0, b equal to plus or minus a, b equal to plus 2 or minus 2 pi a, and b equal to a plus or minus 2 pi. That is, first of all, we can write what is given in the question. U is equal to e raised to ax cos by. Okay, so we have to find out the relation between b and a there. So here, in order to find out the relation between b and a, we can apply the Cauchy Riemann conditions there. In order to apply the Cauchy Riemann conditions, first we have to find out the imaginary part, and we have to check which equation will obey this relation between b and a. So instead of that, we can use an easy method. Here, since the function is analytic, okay, since the function is analytic, that means u and v are harmonic functions there. If the u and v are harmonic functions, that means it obeys the Laplace equation there. What is the Laplace equation? Dou square u by dou x square plus dou square u by dou y square is equal to 0. Okay, so u is equal to e raised to ax cos by. So u is equal to e raised to ax cos by. So what will be dou u by dou x? Dou u by dou x is equal to a e raised to ax cos by, and dou square u by dou x square is a square e raised to ax cos by. Okay. Similarly, we can find out the dou u by dou y. So what is dou u by dou y? Dou u by dou y is equal to e raised to ax cos by derivative. What is cos by derivative? Sin by minus b sin by, and dou square u by dou y square, second order derivative is minus b e raised to ax, sin by derivative is b cos by. So one b will become b square cos by. Okay, so we can apply the Laplace equation there. So what is dou square u by dou x square? A square e raised to ax cos by plus dou square u by dou y square, there is this minus b square e raised to ax cos by is equal to 0. Okay, so this is e raised to ax cos by, this is e raised to ax cos by. So we can write here a square minus b square into e raised to ax cos by is equal to 0. That is a square minus b square is equal to 0, or a square equal to b square, or b equal to plus or minus a. So which option is correct? Second option, b equal to plus or minus a. Okay. So the next question is asked in 2018 June net examination. What is the value of alpha for which the function is analytic? In the function, there is one alpha there. For what value of alpha this given function is analytic? Okay. So if the function is analytic, if the function is analytic, that means we can apply which equations there? Cauchy Riemann equations there. Okay, so for that, dou u by dou x equal to dou v by dou v by dou x equal to minus dou u by dou y. So first we can write what are the real part and imaginary part. Here it is 2x plus 3 into x square minus y square is the real part, and imaginary part is 2 into 3xy plus alpha y. Okay, so here dou u by dou x is equal to 2 plus this is 6x, and dou u by dou y is equal to, here x term, this is minus 6y. Similarly here dou v by dou x is equal to, this is 2 into 3 6y, and dou v by dou y is equal to, here it is y term is here, so coefficient is 6x, here it is y term there, that is plus 2 alpha. Okay, so what are the Cauchy equations? Dou u by dou x equal to dou v by dou y, dou v by dou x equal to minus dou u by dou y. Okay, these equations are true there. Okay, it is already comes there, so there is no alpha term, so we can check this condition. Which condition? Dou u by dou x is equal to dou v by dou y. So what is dou u by dou x? 2 plus 6x is equal to dou v by dou y is 6x plus 2 alpha. So 6x will cancel, so 2 equal to 2 alpha, that means alpha is equal to 1. Okay, so the option A is correct. Okay, but last question, it is asked in 2017 GATE examination. The imaginary part of an analytic function is v is equal to 2xy plus 3y. v is equal to 2xy plus 3y. The real part is 0. So that means u, real part is u, that is equal to 0 at origin. So at origin means 0, 0, x equal to 0, y equal to 0. What is the value of the real part? The value of real part, that is u is equal to at 1 plus I. Okay, so u at 1 plus I. Okay, so at 1 plus I means what is the meaning? That is 1 is x part and this is y part is also coefficient of I, that is y is also 1. So that means the 1 at 1 plus I. What is the real part? That is when x equal to 1 and y equal to 1, what is the real part? So we know how to find out the real part if the function is analytic. Here it is given the function is analytic. So if the function is analytic, the real part we can find out by taking the total derivative of real part. Du is equal to dou u by dou x into dx plus dou u by dou y into dy. Okay, so how the function is analytic means we can apply the CR equation, that is Cauchy Riemann equations there, that is du is equal to dou u by dou x is, what is dou v by dou y into dx plus dou u by dou y is minus dou v by dou x into dy. Okay, so from this, what is dou v by dou x? Dou v by dou x is equal to 2y, and what is dou v by dou y? Dou v by dou y is equal to 2x. Okay, 2x plus 3. Okay, 2x plus 3. So here we can apply dou v by dou y is equal to 2x plus 3 into dx minus dou v by dou x is 2y dy. Okay, du. Okay, next step what we have to do? We have to integrate this. Integral. Here x dx, here y dy. Okay, so that is integral du is u. This is 2x plus 3. Okay, so that when we integrate, this become 2x square by 2 plus 3x minus, this is integration with respect to y, so this is y square by 2 plus constant of integration c, that is this 2 will cancel, this 2 1 will cancel, and also it is given this u is equal to 0 at 0 origin. So at origin what we can apply there? This u is equal to 0, that means at origin means x equal to 0 and y equal to 0. So this is 0, this term will be 0, this term will be 0. So what is we are getting? Constant c is equal to 0. So that means the function is, the constant c equal to 0 means the function is u is equal to x square plus 3x minus y square. Okay, because constant of integration is 0. So now what we have to find out? We have to find out what is the real part at 1 plus I. At 1 plus I means x is 1, y is 1. Okay, that is x equal to 1, y is equal to 1. What is the real part? So when x is equal to 1, this is 1. X 3 into 1, that is 3, minus y equal to 1, 1. That is 1 plus 3 minus 1, that is equal to 3. Okay, so and at 1 plus I, the real part is equal to 3. So in the competitive examination, the questions based on this Cauchy Riemann equations and analytics are very easy. Only we require a proper practice. Okay, so it is not a time consuming. Only we have to remember two conditions. If the function is analytic, we can apply the Cauchy Riemann equations there, and also the real part and imaginary part obeys the Laplace equations. Using that conditions, we can find out most of the answers. Okay, so try more questions. All the best. Bye.